In this video, we're going to review partial quotients, which is a strategy we use to divide. Last year, many of you used a strategy called multiplying up. So if you were solving 132 divided by 12, you would think to yourself, 12 times what would get me close to 132? And then you would start making guesses, like 12 times 10 gives me 120, so I'm close. And then you might try, all right, 12 times 1 is another 12. And if I add those up, I get 132. So, but my answer here is not 132. My answer is how many times did I multiply it? So 10 plus 1 would give me 11. So the answer to the problem is 11. Now this is a great strategy, but as your numbers get bigger, sometimes what happens is you lose track of how much further you have to go, and at the end when you add up, you find you actually went over what you needed to be to. Partial quotients is a lot like multiplying up. It just keeps your information more organized. Some people like to call it the big 7 because when you show your sign, it actually looks like a big 7. So I'm going to think the same way I did with multiplying up. 12 times what would get me close to 132? And I'm going to start with the same guess as 10. So I write my 10 on the side here. That's how much I think it might work, and that's what I'm going to start with. 12 times 10 is 120. So I write my answer down underneath, and what I'm going to do is subtract, because that's going to tell me exactly how much more I need to go. So now I can see how many times does 12 go into 12, and that would be 1 time. And then I can see I got to 0, so there's nothing else for me to do. And my answer is over here on the side. 10 plus 1 gives me an answer of 11. Partial quotients is really helpful when you start to get to numbers that aren't as friendly as 132 divided by 12. So let's take a look at this problem. I start by setting up my problem. The 13 goes on the outside, and the 397 goes inside the house. So I need to pull out groups of 13. So I have to decide how many groups do I want to start with. I always like to start with a number that's really friendly. That means it's something I can easily do in my head. So I'm going to have to start with 13 times 10. So I put my 10 on the outside, and 13 times 10 is 130, so I'm taking out 130, or 13 groups of 10. So I subtract, and I still have 267. So I can see right away, well, I can do another group of 10 to take out another 130, and I subtract. And I have 137. So again, I can do one more group of 10 to take out 130, and I'm left with 7. Now if I have 7, I can't split that into 13 groups easily, so I know that I'm done. As soon as I get to the bottom and I can't split that number into groups, then I'm finished. So I'm going to look at how many times I was able to put 13 in, and that's 30 times, and what's left on the bottom is my remainder, so it's 30 remainder 7. Now if you right away knew that 13 times 20, for example, is 260, because you're able to do that in your head, you can start there. You don't always have to start with 10. The most important thing with partial quotients is you just do whatever's easiest for you to do, and that's going to make it an efficient strategy for you. Either way, no matter where you start, you're going to get the same exact answer. Sometimes when you start, you're really not going to want to start with 10. For example, look at this. If I have 897 divided by 11, and I just do groups of 10, this could take me a really long time. But I can think to myself, well, let's start with something a little bit bigger. Maybe I know that 8 times 11 is 88. Oh, so then if I did 80 times 11, it's going to be 880 because I'm multiplying it by a power of 10. So right away, I see a quick step for me to do. So I'm going to actually start with, I'm putting 11 in 80 times, 80 groups of 11. So then I get 880, and now I can subtract. So I still have 17 left, and I can make a group of 11 out of 17. So I'm going to try and take one group of 11 out. So 1 times 11 is 11, and then I subtract. But when I have 6, I can't make a group of 11 out of that, so I'm done. So my answer would be 81, because that's how many times I put 11 into the number, remainder of 6. So when you see a friendlier place to start other than 10, especially when you're working with bigger numbers, It's always great to start there so you have less steps. The great thing about partial quotients, though, is that if your first guess isn't close enough, you can keep building up to the real answer. So it's an efficient and friendly strategy, and it's a little easier to do than multiplying up, where you have to keep track of everything in your head. Because here with partial quotients, it keeps track of what you have left every time you subtract, so that you never have to worry about going over.